Hello everyone, this is Sumita Gupta. Welcome you all for my next lecture of electronic devices and circuits. Today we will solve some MCQs on AC load line, small signal analysis of common emitter and common source amplifier along with multistage amplifier. So especially this subject is for electronics and communication students for second year. Um, Basically, it is designed for the Mumbai University students. Okay. Now, question one is transistor with beta equals to 120 to operate a DC collector current of 1.2 milliampere. Find the value of GM. Okay. So first of all, what is given beta and IC, and it is asked you have to calculate the value of GM. So you should always keep in mind what is the expression of GM. So GM is equals to IC by BT. Okay. What is IC? What is BT? IC is your collector current and BT is your thermal voltage. BT may be given or may not be given in the numerical. So BT, you know, it is KT by Q. K is your Boltzmann constant, T is your room temperature, Q is the charge of electron. So when you will put all the values, the value will be approximately 25 millivolt. So just put this value in this equation. IC is your 1.2 milliampere and BT is 25 millivolt. When you will solve this, the answer will be 48 milliampere per volt. Okay. Um, Now next is the transistor with beta equals to 120 is biased to operate a DC collector current of 1.2 milliampere. Find the value of R pi. Okay. Now you should know what is R pi. R pi equals to beta by GM. Beta by GM. Since the value is same, beta 120 and IC 1.2, same as previous one. So GM will be 48 milliampere per volt. So what is R pi? Beta is given 120 divided by, what was it? 48 milliampere per volt. When you put value of this, 48 into 10 raised to minus 3, when you will solve it, your R pi will be 2500 ohm. Okay. Now next question is, which of the following is true? So remember what is beta? Beta equals to IC upon IB. Beta is your current gain for common ammeter. It's a ratio of collector to base current. So definitely which parameter is constant? Ammeter. Okay. So when ammeter current is constant, or we can say it's a current gain for common ammeter configuration. So as per this, IB equals to IC upon beta. What is the SI unit of transconductance? You know what is transconductance? Transconductance is I by B. What is the unit of I is ampere. What is the unit of B is volt. So SI unit of transconductance is ampere per volt. What type of signals does a transistor behave as a linear device? Definitely small signals, because there will be very less variation. So whatever the approximation, it looks like a linear. The phase difference between input and output of CE amplifier is definitely, you know, the CE transistor, common emitter transistor behave like an amplifier, inverting amplifier. What do you mean by inverting amplifier? Inverting amplifier means when if you will provide the input like this, then your output will be like this, just opposite of input. Means if it is input is plus 5 volt, output will be minus 5 volt. So what is the phase difference? Definitely 180 degree. So always remember, in any amplifier, the phase shift is of 180 degree. Okay. Now, when AC signal is applied, then operating point moves along. As per the AC signal, Q point will move along the AC load line. Okay. Now, input capacitor of an amplifier is definitely, always remember this concept. I'm taking a general diagram. Okay. So here it is a, suppose there is a AC input coupling capacitance, output coupling capacitance, and bypass capacitance. The three types of capacitance used. The capacitor connected to input is input coupling capacitance. Capacitor connected to output is output coupling capacitance. Capacitance connected to ground is bypass capacitance. Apart from this, stereo junction capacitance that are different. So what is asked in the question? The input capacitor and an amplifier is coupling capacitor. If it is asked output capacitance, then you can also write coupling capacitance. If it is asked the capacitor connected to ground, then you will say it is a bypass capacitor. Okay. The point of intersection of DC and OC load line is, see that this is the OC load line, this is your Q point. Okay, and this is your AC load line, then this is also. So Q point remains same, but load line changes. So point of intersection between two lines is operating point, or you can say Q point. Slope of AC load line of definitely the slope of AC load line is more than the DC load line. Okay. The purpose of capacitor transistor is definitely, if it is a coupling capacitor, its purpose is to couple the signals, means to block the DC and pass the AC. Simple. Or we can say bypass AC component means pass the AC signal. So purpose of any capacitor is to block DC and pass AC. Okay. In the DC equivalent circuit of transistor, the capacitor is open circuit. Why it's open circuit? See, suppose this is the circuit. Okay. This is the circuit, and this is your coupling capacitor. Okay. Now here we are applying input. Now we want DC analysis. For DC analysis, what we assume, the capacitor is open circuit. So that's why whatever the input signal, it doesn't affect the biasing of the circuit, DC biasing of the circuit. Due to this capacitor open circuit, there is no effect of input to the your main circuit. I guess this point is clear. Again, listen carefully. Suppose this is your amplifier and this is your capacitor and this is your AC signal. If this capacitor is behave like open circuit, means whatever AC input, it doesn't affect your DC biasing circuit. So for any DC equivalent circuit, we assume that means the capacitors are considered open circuit for the analysis. Now the next question, if RC and RL represent the collector resistance and load resistance, then what is the actually load? See, whenever we draw the small signal analysis model, suppose this is your circuit and this is your RC, and here it will be load resistance RL. Okay, when we draw the small signal equivalent circuit, suppose this is capacitor, base, ammeter. So in this small signal, what will happen? There will be a one current source. Okay, then after current source, at collector RC and RL both will take in parallel. Then we will count this is actual load, main output. So in output, both resistors are in parallel. So actual load is RC parallel RL. If you want to know in detail, please go through the lectures of small signal analysis of common emitter amplifier. There I have explained in detail the whole derivation. Okay. Now for AC equivalent circuit means we want to connect the circuit. Means this is your circuit. Okay. This is your circuit. Now what we want? We want to connect the AC. So for connection of AC, what we will do? This is your AC signal. Okay, and so DC will be grounded, and for doing AC analysis, AC signal should be there. So how signal will be connected? When this capacitor will be short circuit. When this capacitor will be short circuit, then this AC signal will be connected to the main circuit. Then we will do the analysis. So always remember, for DC analysis, capacitors will be short circuit. For AC analysis, capacitors will be open circuit, but this both is the case for the mid-frequency analysis. Always remember, for DC analysis, capacitor short circuit. For AC analysis, capacitor open circuit, but both are the case of mid-frequency. For low frequency, your coupling and bypass capacitors will be connected. And for high frequency, your junction capacitors will be connected. Again, for detail, you have to go through the previous lectures. Now, an amplifier has a power gain of 100, so it's dB gain. So, power in dB is 10 log base 10, and whatever your power. So, for this case, 10 log base 10, 100. 100 means 10 raised to 2. When 2 will be here, so 2 into 20 into 1. Sorry, 10 into 2. 10 into 2 equals to 20. So answer is 20 dB. In order to get more voltage gain from the transistors, definitely more voltage gain, we want more output, more current. So definitely base should be very thin. Then you will have the maximum current. The purpose of coupling capacitor I have already explained, to block the DC and pass the AC. Okay. The purpose of ammeter capacitance. Ammeter capacitance means if you look at the common ammeter, so we just generally connect one resistance along with the capacitance, or we can say it is a bypass capacitor. Okay, so its role is to it will not let the voltage gain down, so it avoids voltage gain to drop. If the input capacitor of transistor is short circuit, then definitely I have already explained this is your input. If it the capacitors if the input capacitor of amplifier is short circuit, what will happen? If it is short circuit, it will affect the main circuit. That's why what I have explained, for DC analysis, capacitor should be open circuit. If it was open circuit, your biasing circuit will be changed. Your biasing condition will change. In a CE amplifier, uh, it is also called as grounded ammeter, because common ammeter is grounded ammeter. DC load of transistor amplifier generally, definitely DC load is more than the AC load. Okay, our transistors amplifier is high. Always remember, for BJT transistor amplifier, it has a low input impedance and high output impedance. Remember this: low input. Low input impedance and high output impedance. Okay, so for this purpose, collector should be reverse bias. For highest power gain, definitely common emitter configuration. Now see, in the question, it is called CC configuration used for impedance matching, because CC common collector. So generally for BZD, we assume input impedance low, output is high, but in common collector, the case is different because it behaves like a meter follower. So in this case, input impedance is high. If RC and RL are collected load resistance and AC load resistance, I have already explained the small signal model. This is RC and this is your RL. At collector, both resistance will behave like in parallel combination. So it will be RC parallel RL. And you can also write RC into RL upon RC plus RL. If current gain and voltage gain of amplifier is X, means your current gain is X, your voltage gain in Y. Okay. So power equals to voltage into current. Voltage is Y, current is X. So power is X into Y. Which is the following technique can be used in sinusoidal AC analysis of transistor? Two types of analysis. Small signal analysis or large signal analysis. Remember. Okay. So the input impedance of BJT amplifier is, remember, input impedance. Impedance means VYI, or it can also write resistance. So input impedance is purely resistance in nature, and it can vary from ohms to mega ohm, from low to high. Okay. What is the typical range of output impedance common ammeter? It ranges from 40 kilo ohm to 50 kilo ohm. The ammeter follower configuration, remember the ammeter follower means common collector. In common collector, input impedance is high and output impedance is low. So answer is high and low. Peak value of AC input signal is controlled by whatever voltage we are applying. Apply DC voltage. Okay. The common ammeter configuration. Common ammeter means ammeter is grounded. So what is input terminal? Base. What is output terminal? Collector. Because ammeter is grounded. So input is base, output is collector. So what is the controlling current? Base current. What is the controlling parameter? Collector current. So answer is IV, IC. Output voltage, input voltage, common ammeter. I have already explained. The common ammeter is your inverting amplifier. Inverting amplifier, the ratio relation between input and output is If input is like this, then output will be just opposite of input. So 180 out of phase. In a voltage divider bias configuration, what is used to determine? If you remember, voltage, what is voltage divider rule? This is R1, this is R2, R1, R2, and this is your VCC, and here this is RA. We want to calculate voltage across this. So how to calculate? R2 upon R1 plus R2 into VCC. It is called voltage divider rule. So from this we will calculate dB, base voltage. So base voltage is equals to R2 upon R1 plus R2 into VCC. So finally what we are calculating? DC level of base voltage. Ammeter follower voltage gain is, ammeter follower means output voltage follows the ammeter voltage. Means output should be approximately equals to input. That's why it's called follower. But this is ideal condition. Practical, the value is slightly less than 1. In ammeter follower, the output voltage is now. I have explained you common ammeter behave like an inverting amplifier, but ammeter follower is not like that. Ammeter follower output exactly follows the input. Output exactly follows the input. Practically slightly less than, but ideally both behaves like a same. Ammeter follower means output follows the ammeter, follows the input terminal. So in this case, output should be in phase of input, not out of phase. Okay. The DC load line and AC load line both have same Q point. Okay. Consider the assertion given below. First point is replacement of each coupling and bypass capacitance by short circuit, replacement of transistor by hybrid equivalent model, and replacement of DC voltage source by short circuit. These are the steps for the small signal analysis. But what is the sequence? So please remember, suppose this is your circuit. I am taking everywhere voltage divider because that is mostly used circuit. Okay, now there is some DC supply, DCC, or here it is input. So first step, always remember we have to ground it this DC voltage. So what is the first step? Replacement of DC voltage by short circuit. Second step, whatever the here capacitance are, those capacitance are short circuit. So replacement of capacitance by short circuit. And third, this replace this whole model into small signal equivalent circuit. So what is the step? First is C, then A, then B. Means first of all we have to ground the DC supply, then short circuit the capacitance and convert this model into equivalent circuit. Which of the following is true about common source? Common source, now we are talking about the common source becomes now on FVT. Okay, so whatever, whether it's a common ammeter or common source, both behave like a inverting amplifier. So whatever the output, that is the inverting of the input. So we'll have phase reversal voltage output. Now sinusoidal voltage has 1.5 volt at t equals to 2 seconds. If the signal is given to common source amplifier, the voltage gain is now 5 volt. What is the output? Now input is given 1.5 volt at t equals to 2 seconds, and they are asking the output at the same time, 2 seconds. So you know what is voltage gain? Voltage gain is output upon input. Output upon input. So output equals to voltage gain into input. So voltage gain is your 1.5, input is your 5. So 1.5 by 5 is 7.5. So generally what you will do the mistake, you will click on plus 7.5. But see, it's talking about common source amplifier. In common source amplifier, what is the output is 180 degree out of phase with input. So answer will be not 7.5, it will be minus 7.5. And students used to do this mistake, they just click on 7.5. Okay, so remember this is a phase reversal amplifier. Okay, now for self-bias amplifier, if the resistance of its source and drain both are same, then output will be definitely it's a common source amplifier. can be same with input, but with phase reversal. Phase reversal is an important parameter. Okay. Which phenomena occurs between an input signal at gate and output the drain in the operational mode of common source amplifier? Again, the same thing. Amplifier means it's inverting amplifier. So whatever the output is 180-degree out of phase with the input. So what happens? Phase inversion. There is no inversion of frequency, no amplitude, no phase inversion, only phase inversion. Okay. What is transconductance? Transconductance, remember the ratio of current to voltage. Okay. So for BJT, it equals to IC by BT, collector current upon thermal voltage. Or for FET, it will be drain voltage divided by gate to source voltage. Okay. Now see, the first one is ratio of drain current to collector current. So drain current means they are talking about FET, and collector current they are talking about the BJT. So both can't be same. Either it should be both parameter of BJT or both parameter of FET. So option A cannot be. In option C, they are talking about collector current to drain current. Both have current. So transconductance is not the ratio of current. And D option, they are talking collector current for BJT and gate to source voltage for FET. So both parameters should be either of BJT or FET. This is also wrong. Now the second option is ratio of change in drain current to change in gate to source voltage. This is okay. Now for FET, graph is drawn taking voltage VGS in x-axis and drain current in y-axis. If value of x means VGS. VGS is changes from 10 to 20. Next y means current is changes from 2 to 3. What is the value of transconductance? Transconductance is I by B. What is the change in I? I changing from 2 to 3 means change is 1. VGS changes from 10 to 20, so changes is 20 minus 10 is 10. So 1 by 10, the answer is 0.1. Okay. Now the slope obtained in VGS versus ID was 0.002. What is a GM? So VGS versus ID itself says it's a GM. The value of GM is 0.002. Which of the following expression of GM? Remember, the expression of GM equals to GM naught 1 minus VGS upon BP whole square. Okay, this is for transconductor. Now for GM naught, the expression is 2 IDSS upon BP. 2 IDSS upon BP. This expression is same for a JFET and D MOSFET. It is not used for E MOSFET. In small signal equivalent model or FET, what does GM stands? What is small signal model? This is your common source, drain, gate. When you will draw the small signal model, this is your drain. Here there is a current source, GM VGS. Here it is gate. This is your VGS, and this is a current ID. So what is this GM You can see here, this is your current source, but depend on voltage. So answer is voltage controlled current source. GFET or FET is a unipolar device. What do you mean by unipolar? Means whatever the current conduction, that is controlled by either electron or holes. But in BJT, controlling is done by both electrons and holes. So FET is a unipolar device. The gate of JFET is always, remember, I have already explained in the during the lecture. The gate of JFET is reverse bias and gate current is always 0. Okay. When drain voltage equals the pinch of voltage, and drain current definitely remains constant. If you remember the concept, when both point will meet, when both meet, that pinch of occur and the current will be at maximum level only. Okay, that is current will be constant. MOSFET has how many terminals? 4. Drain, gate, source, and body terminal. MOSFET can be operated both positive or negative gate voltage. If VGS 0 means we are not applying anything at the gate, and drain current constant when the voltage limits the pinch of voltage. IDS is your maximum drain current, but at that time when VGS is 0 volt. The frequency response of transformer coupling. Now it is this is a question for multi-stage amplifier. When we use transformer coupling, then we get a lot of distortion. So frequency response is very poor. Voltage gain, definitely voltage gain always expressed in decibel. Up there are three stages, one stage, two stage, three stages are connected in serially. The gain of first is 10 dB, second of 6, third is 15 dB. So what is the total gain? Remember the gain, total gain is multiplication of each gain. AB1 multiplied by AB2 multiplied by AB3. But we will take the log of this, then all parameters will be added up. And we will take log, so it will be log A1 plus log A2 plus log A3. Why I am talking about logarithm value? Because all the values are given decibel. So when we will add up all this, 10 plus 6 plus 50, it will be 31 dB. So don't be confused in such type of questions. Which transformer is used for impedance matching? Definitely step down. Okay. The total gain of multi-stage amplifier less than the product of gain of individually. Yes, actually we write this A equals to A1 multiplied by A2 into A3. But what's happened? Actually, this value is approximately same. Means there is it is less than the multiplication of gain. Why it's happened? Because one stage output is the input of another stage. Another stage output is the input of another stage. So due to this stage by stage coupling, the loading effect is there. Due to loading effect, your main output gain, total gain can be less than the multiplication of individual gain. The gain of amplifier usually expressed in decibel. Why it's always used in decibel? It's a small unit, calculation easy, gain is low. Human ear response is logarithmic. Whatever the human hearing is, that is log in nature. For doubling the data, the sound power is generally increased by the 10 times. Means the gain of amplifier is control sound intensity, that should be in power of 10. So which is in 10 means it's like in a bell shape. So that is called uh, 10 decibel scale, or we can say human ear response is logarithmic. So thank you so much. God bless you. Take care. If you want any help, you can write in chat box. God bless you.